So now we are going to continue the concepts of satellites, sort motion of a satellites, orbital velocity, and what is the time period, and based upon the time period and the distance away from the satellite, what is the types of satellites. That is what is our today's class. So now we know that in last class we have found orbital velocity means normal case. If you take the orbital speed, what is the formula? We got it, everybody. So generally we have discussed that if you take any kind of a satellite, so which is revolving around the earth, if you have taken, so revolving around the earth, so we all knows that there is a force of attraction which is always acting towards the center. That is what is the centripetal force, everybody? What is the centripetal force? Centripetal force is equals to mv square by r. mv square by r. Now this centripetal force is acting because of gravitational force. So we all know that force of attraction because of gravitation between the two bodies is equals to what? Capital G into capital M into small m divided by distance between the two bodies from their centers. So now, as we know, centripetal force is acting or provide gravitational force only providing the centripetal force. So we can say centripetal force is equals to a gravitational force. So the force due to gravity, so which is equals to what? So mv square by r is equals to capital G into capital M into small m divided by r square. So small m will get cancelled, r will get cancelled. So V is equals to root over capital GM divided by R. This is what is the formula which we got it in our last class, which is for the what, everybody? Orbital speed or orbital velocity. So now, if you have taken, if the satellite is revolving very close to Earth surface, very close to Earth surface, so then we all people knows that almost the distance between the satellite and the planet of the earth, which is equals to what, everybody? Very close to the earth, if it is revolving, then approximately the distance between them, which is equals to what, all of you? Distance between the satellite and the earth, that is what from the satellite, which is equals to the radius, that is what approximately r is equals to r. Then that orbital velocity is equals to root over gm divided by r. So we all know that this r become what? Radius of the earth. So now from the gravitation formula, acceleration due to gravity is equals to gm by r square. From that, gm is equals to gr square. So I'll replace gm with a gr square. So gr square by r. So r square and square will rr will get cancelled. So v naught, orbital velocity very close to the earth surface, which is equals to small gr, root over small gr. So this is the formula where the satellites are moving very close to the what, everybody? Very close to the earth surface. That is what you have to remember it. Now, as we know that for earth surface, which the satellites are very closer to the earth surfaces, so V naught is equals to root over GR, approximately how much, guys? That value. If you substitute the radius of the earth, yes, please. So we all knows that the radius of the earth is equals to 6400 kilometers. And if you substitute that value, approximately we'll get how much, everybody? 7.9 kilometer per second, which is equals to approximately rounding off to 8 kilometer per second. So that is what. So for satellites, always, if you want to revolve the satellites closer to the earth, this is the orbital velocity, which is approximately 8 kilometer per second. So now later that we have been found the relation between orbital velocity and escape velocity. So what is the orbital velocity and escape velocity relation? Escape velocity is equals to root over 2 times of orbital velocity. That is what we got it in a yesterday's class. Am I right, guys? Everybody? So remember, velocity, escape velocity is equals to root 2 times of orbital velocity. And if you see the difference, What is the difference, guys? Escape velocity and orbital velocity, everybody? What is that? How much you got? Escape velocity is 11.2, orbital velocity is 7.9. What is the difference, everybody? Yes, please, which is equals to approximately 3.3 kilometers.
3.3 kilometers.
So up to here, we have solved in the yesterday's class. Those who not attended, I think you might be remember this. Am I right? Murali, Rudreswar, completed. So up to here, you have to remember that. This is what is about, what is the orbital velocity and orbital, escape velocity. So now, based upon this, in JEE Advanced, so there is 2011, they asked the question exactly based upon the similar principle. They asked the question. So let us see now, everybody, write the question. A satellite revolving around Earth orbit, an object of mass m, an object of mass m is ejected from satellite. Please remember that. So some mass is thrown from the where, everybody? Some mass is thrown from the satellite such that it escapes gravitational. It escapes the gravitational pull of Earth. So the object is not thrown from the Earth surface, from the satellite surface, who is having mass m, Earth surface. If the speed of satellite, do you understand the Prado's question? If the speed of satellite is v, that is what? Constant. The satellite remains constant. Find kinetic energy of our object at the instant of ejection. At the instant of its ejection. So that is the question. So option A, half mv square. Option B, half m, let me take v naught, orbital velocity, v naught mv square. Option C, 3/2 mv naught square. Option D, 2 mv naught square. So let us see that. Who will find it? Make it quick. Try the question. So first I will explain the question, you can see. So we all knows that planet of Earth is present. So this is the Earth. And in a particular orbit, who is revolving, everybody? Who is revolving? In a particular orbit, satellite is revolving. Satellite is revolving in a particular orbit. From that some mass m, whatever it is, this is what. So from that, which is revolving with the v naught velocity. So from that some mass m has been thrown out with the escape velocity v. So that is what? So that if you have been thrown from the satellite, it is escaping from the Earth gravitational pull of the Earth. Then calculate this velocity they are asking. Are you clear, everybody? Do you all understand, Amma? So now, this is very simple concept. For example, if I am traveling in a bus, a bus speed is equals to, let me take 20 kilometers per hour. Now, at that moment, if I jump from the bus and if I fall into the road, then my speed also how much, guys? My speed also how much? Yes, please. Same 20 kilometers per hour. Am I right or wrong? So whatever the speed of bus, the same speed for me also. Am I right, guys? Everybody?
Yes.
Do you understand? Yes. Now, if this object of mass m is ejected or it is thrown from the satellite, so if it is thrown from the satellite means whatever the velocity of the satellite, the same velocity of the object also. Am I right, guys? Will you all agree with me? Do you understand?
Yes.
All of you? So that is what. So we all knows that kinetic energy is equals to half m escape velocity square. So we know that satellite velocity is v naught and escape velocity and satellite velocity. What is the relation between escape velocity and satellite velocity? Everybody. Escape velocity is equals to √2 times of, please respond, √2 times of satellite, that's what orbital velocity. So √2 into v naught whole square. So that's all it is answer. If you have done that, you will get it. So half into mass into root 2 whole square what? Everybody. Root 2 whole square 2. Am I right, guys? Into V naught square. So 2 will get cancelled. That's what square and root will get cancelled. So what is the answer? M V naught square. That is the answer. So which is the correct option, everybody? M V naught square. So this is the option. M V naught square is the escape velocity of the mass M. Escape velocity of the mass M, which is thrown from the satellite. I hope you all understand. Mr. Pradosh, Rudreswar, clear? Anything doubt? Let me ask. Yes, do it fast. Any doubt? Anybody can ask. Prince, you understand, Prince? Murali?
Yes, sir.
Yeah. So it's very simple sum. Sometimes they will ask even very small terms, but you just have a complete idea. That's all about it. Okay, I hope you all understand. Anybody having any doubt, you can ask me. Otherwise, we'll proceed further. Are you clear, Mr. Rudreswar?
Yes, sir.
Any doubt, anybody can ask. That is. So next, we are going to calculate the time period of revolution of a satellite. So what is the time period for? We know that Earth will take how many days to revolve around the sun? Everybody, 365 days. Am I right or wrong, everyone? So like
Yes,
that, different planets will take different time to revolve around the sun. Same way, different satellites will take different time period to revolve around the Earth. So basically, whatever the satellites we are launching, so based upon the distance away from the sun, so some satellites are revolving very closer to the Earth, some satellites are revolving very far away from the Earth, and some other satellites are moving more even far away from the Earth. So based upon the distance away from the sun or the Earth, whatever the orbit we are launching. So let me take, this is the Earth I am saying. So whose mass is M? And let me take first one. So suppose the satellite is revolving at this orbit. This is the satellite. Now distance between them, let me consider as a R. Distance between the two bodies from their centers. So we all knows that if the satellite is revolving around any planet, centripetal force is equals to force of gravitation. That's what. So V is equals to root over Gm by, speak everybody. What is the formula? Root over Gm by R. But if you take the Earth surface, if any satellite is revolving around the Earth very closer to that, then what is the orbital velocity formula? Everybody. Orbital velocity formula, Earth surface. Close to the Earth surface. What is the orbital velocity formula? Just now I have told. What is the orbital velocity formula? If it is moving closer to the Earth, closer
Root
surface
GR.
to the Earth, root over GR. My formulas don't know. Physics is not at all possible. So that is what it is. Root over GR. That is what. Now, what is the time period to revolve around this is similar to the speed formula. We all know the circular motion. So circular motion, what is the speed formula? Anybody can tell? Circular motion, speed is equals to, yes. Circular motion speed is equals to what, everybody? Circumference of a circle divided by time period. That's what T. So circumference of a circle is how much?
2 pi r.
Circle 2 pi r by T. So now T will come here. So time period is equals to 2 pi r by V. That is what speed of the body. So this is what is the time period formula. So now let us see. We will replace the time period. That is what velocity of the orbital velocity V for the normal case, and we will try to find the time period and radius. For example, the satellite is revolving here. The satellite is revolving here. We studied Kepler's third law. Anybody can remember Kepler's third law? What I taught you? Anyone? Kepler's square of time period of any planet is directly proportional to cube of or average radius between the planet and the satellite, or Earth and the sun and the Earth, whatever it is, sun and the planet. So for every planet, it remains constant. Am I right, guys? Everybody? Yes or no? If you do the square of time period divided by cube of average radius between the sun and the any planet always remains what, everybody? You'll get always remains constant. That is only call it as a Kepler's third law. So let us see that now, how it will be possible, and we are going to find it now. So if you all notice it, everybody, so time period is equals to what is the formula, all of you? Time period is equals to 2 pi r by v, a speed. So now speed I will replace with the formula. We all knows that speed of a satellite or orbital velocity is equals to root over GMR. So that is what 2 pi r divided by root over GM divided by r. So now I will write this one. You can see, everybody. So 2 pi r divided by, can I write this one as root means what? Can I write, all of you? Please respond. What do you mean by root? So I will write root over GM by, yes, please. What do you mean by root, brothers? 1 by 2.
R.
Yes.
1 by 2.
So r power 1 by 2. This r power 1 by 2 will come up. So what will happen, everybody? Check it, everyone. So 2 pi r divided by root over GM, which will become what? Nothing is there, means r power 1 plus r power 1 by 2. So now, which will become into what? 2 pi r power 3 by 2 divided by root over GM. This is what it will be becomes. So now if you see, that's what the time period formula. So if you take here now, all of you, so from the acceleration due to gravity, which is equals to capital G into capital M divided by r square, from that GM is equals to what, everybody? GR square. Am I right, guys? All of you? Do you understand, everyone?
Yes,
so now
sir.
I'll replace in place of GM,
Yes, sir.
place 2 pi into r power 3 by 2 divided by root over GR square. So now, if you observe this formula, it's very simple. 2 is the constant, pi is the constant, g is the constant, radius also constant. So this all the terms are constant. Only what is not constant, everybody? Distance between the planet and the satellite alone is not constant. Am I right or wrong? That r is varies. This r is always varies. It is not same for every satellite. Am I right? Please respond. So r alone is not constant. Remaining all are constant. So let me consider this, all the things, 2, g, r, pi, everything is constant. I will take it as a constant k into r power 3 by 2. All are constant. This all are remains constant. So now I will do both the sides. You can see constant and equals to, if I remove it, I will take it as a proportionality again, reverse back. Proportionality remove, you will take equals and constant. Now reverse, it will get proportionality. So t directly proportional to r power 3 by 2. Now do square on both the sides. What will happen, everybody? Square on both the sides, everybody do it. Yes, what will happen, Rudresha? Square on both the sides, what will happen? T square is directly proportional to r power 3 by 2 into whole square. So square, that's what? 3 2s are 6 divided by 2, which will becomes, what will happen, everybody? T square is directly proportional to r cube. That is what it will be happening. So that is only the Kepler's third law. Square of time period is directly proportional to square of time period directly proportional to r cube of average radius between the planet and the satellite, or sun and the planet, whatever it is. That is what is the Kepler's third law. So this is how the time period of a satellite. Now, how much it is? If it is Earth's very close to the Earth's surface. For example, if you have taken, all of you remember, any kind of satellite is at an altitude of r. R means radius of the Earth above the Earth's surface. Above the Earth means in the sense of, so the Earth is present here and the satellite is also present r, which is equals to radius of the Earth. So radius of the Earth is r, and again the satellite is present r above, that is what h is equals to r. So here the satellite is revolving. Now, can you tell me what is the distance? Small r is equals to total distance between the centers. Centers, r is equals to what, everybody? R is equals to r plus h. So h is equals to r. So r plus r. By the time r is equals to what, everyone? R is equals to
2R.
2r. So that is what you have to remember. If the satellite is revolving, exactly the distance away from the earth, which is equals to the radius of the earth, then the r between them, the distance between the satellite and the earth from the centers is equals to r plus h, which is equals to h is equals to r. So r plus r, which is equals to 2r. So that is what you have to remember. Now, if I take what is the time period, if it is closely moving towards to the earth surface, what is the time period? If the satellite is moving very close, remember most of the satellites what we are launching, our India or whatever the country, majority of them, they will revolve around the earth very closely. So if you take very particular satellite, which is revolving very close to the earth surface, the time period, particular satellite, the time period is approximately 84.6 minutes. So within these minutes, it will make one complete revolution around the earth. Around the earth, it will make approximately 84.6 minutes. It will make complete revolution around the earth. Which one? A particular satellite which is very close to the earth surface. So it has been calculated. How it will be calculated? It's very simple. So if it is very close to the earth surface, we all knows that the distance between the planet and the satellite, sorry, earth and the satellite, which is equals to something. Anybody? What is that? Which is equals to distance between them, which is equals to what? R is equals to radius of the earth. Am I right or wrong? Approximately. Yes, guys. So we all know that
Yes,
time
sir.
period is equals to 2 pi r by v. Now, whenever the r, which is very close to the earth surface, r is equals to r approximately equals to radius of the earth. So that the formula will turn 2 pi r by v, where r is approximately equals to radius of the earth. So now, we all knows that if it is very close to the earth, what is the orbital velocity formula? Pradosh, close to the earth, what is the orbital
Root
velocity?
over GR.
Root over gr. So 2 pi r divided by root over gr, very close to that. Now you can see, all of you. So see, basically gr, root over gr is basically very close to the earth. What about the normal case? If it is the normal case, what is the formula? R is approximately R. If it is a normal case, what is the formula? Root over gm by r. Am I right, guys? Yes or no?
Yes, sir.
That is it.
Yes, sir.
Now, if I replace whatever it, they will take this formula, V is equals to, we basically will calculate the time period by this also. Or else we take the normal case, we all knows that root over gm by r. So I will replace this one. 2 pi r divided by V means root over gm by r, sorry, small r, but where r is approximately equals to radius of the earth. So I will get it 2 pi r divided by root over gm by r. So we all knows that again same formula will come. Actually this only will come. Just I am saying you again if you want to get it normally. So what we'll do again now? From the acceleration due to gravity, gm by r square. So gm is equals to gr square. So if we substitute it, again what will happen, everyone? Same formula will come. So 2 pi r divided by root over gr square divided by r will get cancelled. So what is the final answer? 2 pi r divided by gr. We got the same answer or not? Mr. Rudreswar, clear? Yes?
Yes, sir.
That is. Now, both numerator and denominator multiply with the root r. And can you tell me what will happen, everybody? Root r and root r if I multiply. So 2 pi r into root r divided by root g into root r into root r. What will happen? Root r whole square. So square and root will get cancelled. So we'll get 2 pi r into root r divided by root g into r. So RR will get cancelled. So what is the answer? Anybody? What is the answer? 2 pi into root R divided by root G. So 2 pi into root over R by G. Have you remembered this formula? Somewhere we have been used it. Time period T is equals to. So time period T is equals to when it is very closely, any planet is moving very closely to the Earth surface, then that time period is equals to 2 pi into root over R divided by G, which is approximately how much it will come? Any particular planet which is moving closer to the Earth surface, which is equals to 84.6 minutes. That is what, if you solve these values, everything will get approximately 84.6 minutes will come. So if you want, you can substitute it and you can solve it. I hope you all understand. Anybody having any doubt, you can ask me. Are you clear, everybody? Yes, please.
Yes,
Yes, sir.
sir.
So now, next, this is what is about time period concept. So next concept is energy of a satellite. So now let us see energy of a satellite. If you have taken, all of you observe very carefully. So how much energy it is possessing when the satellite is revolving around the Earth. So if I take the Earth, whose mass is m, now the particular orbit the satellite is moving. So let me moving a mass m, that's what satellite, whose velocity is v, and the distance between the from the centers is equals to r, which is equals to r. So now if you notice it, everybody, so what is the kinetic energy of this body? And sorry, we want actually energy of a satellite. So if the body is moving in a particular orbit, we know that it will possess, every point it will possess kinetic energy and as well as potential. So what is the kinetic energy of the body of this mass m? Everybody, half into m into v square. Am I right, guys? Everybody? Yes or no? Please respond. So which is equals to, we all knows that half into m into, what is the v? V is equals to what? V is equals to root over gm by r. So square will come this side. V square is equals to gm by r. So I'll replace in place of v square. What I can write, everybody? What I can write, guys? Half into m into small m divided by r. This is the formula for kinetic energy. So the kinetic energy possessed by a body is always a positive, that is what satellite, and that is value is half g into, sorry, here g is missing. So where is that g? G is missing. So g into m divided by r. Now what is the potential energy? Anybody? Two objects. What is the potential energy? We already studied that. Anybody? Potential energy equals to, yes please. What is the potential energy formula, brothers? Capital minus of capital G into capital M into small m divided by distance between the two bodies from the centers, which is equals to R. Am I right? Yes, please.
Yes, sir.
Yes. So this is only, we can say what? Gravitational potential energy. Gravitational potential energy between the two bodies is this one. And this is the kinetic energy. So now we want energy of a satellite. That is what? Total energy. So if I take the total energy, means we all knows that it is sum of two energies. What is that energy? Kinetic energy plus potential energy. So if I substitute kinetic energy is G into m divided by 2R, but here I have done what R I have substituted, not small r. So Gm divided by R and R. If I make any error in writing, you can tell me. Small r. So kinetic energy is equals to plus G into capital M into small m divided by small r. Next plus minus of, what is the potential energy, everybody? Minus G into capital M into small m divided by R. So now in this both, one is constant. What is that? Capital G into capital M into small m is constant. And I'll take this one, as you can see. Of course, in both the cases, R is also constant. So I'll take R out. Then what is remaining here? 1 by 2 is remaining, plus into minus, which is equals to 1. So if I do it, G into capital M into small m divided by R, which will turn up into 1 minus 2 by 2. So which is equals to capital G into small m into capital M divided by R, which will become minus 1 by 2. So which is equals to what, everybody? What is the total energy? Total energy equals to what, everyone? Speak, guys. Minus G into capital M into small m divided by.
2R.
2R.
So now, if you notice it here, why the total energy is negative? Anybody can tell? This concept I already taught you. Anybody can tell? Why the total energy is negative? Because we all knows that in chemistry, the electrons revolving around the orbit is what energy? Free energy or binded energy? The electrons which are revolving around the orbit, which is binded by the nucleus. Am I right or wrong? So as I told you, binded force. So the binding energy is always which energy? Yes, brothers, check your notebooks. I have taught you already. So binding energy is a what energy? All of you. Binding energy is always what energy? Negative energy. Understand? So always same like the planet, the satellites are revolving around the earth, or the planets are revolving around the sun. Whatever it is, they are binded by the earth. They are completely binded by the earth. Always they are trying to, force is exerting towards the center of the earth. So that is the reason. Always keep in mind, because of binding energy, how the electrons are negative, because they are binding by the nucleus. That is the reason. Same way, the earth is the satellites are revolving around the earth is binded by the gravitational force of the earth. So that is why if the planets bounded always the satellites towards to them, that is why their energy is negative. So when the satellite is revolving in a circular track or the elliptical track, whatever it is, always, what is that, guys? Everybody? What is that, everyone? Always energy. When it is taking a circular track or elliptical track, whatever it is, energy is always what, everybody? Energy is negative because it is binded. So, like how that electrons revolve around the nucleus, everything, same way like satellites are revolving around the earth. So, the total energy, if you have taken the total energy, that is what kinetic energy plus potential energy, always we will get it negative, because this is also bounded energy by the earth, which all the satellites are revolving around the earth. That is the reason. So now, if you take, always keep it in mind, the earth and the planet, satellite, the distance is r, and the potential energy, gravitational potential energy between them, if I consider as a minus x, keep it in mind, then kinetic energy will be exactly plus x by 2 it will be, and the total energy will be always minus x by 2. That's what we got it. What is the total energy? Everybody check it. Minus G into M divided by R. This is what is the total energy. So what is the kinetic energy? Verify, everybody. What is the kinetic energy? Gmm divided by 2R. This is what is the kinetic energy. And what is the potential energy? Minus Gmm divided by R. So the total energy is always the half of the potential energy. That is what you have to remember, because this always you can write this minus Gmm by divided by R, I can write as a potential energy. So U by 2, that's what it is, E. The total energy is always U by 2. So U is what actually? Minus G into capital MM divided by R, and divided by 2 it is, which is equals to minus G into MM divided by 2R. This is what is the total energy. I hope you all understand. Ishali, Laksha, understand? Everybody?
Yes, sir.
Yes. That is what. So,
Yes, sir.
if I take the satellites around the earth, or the electrons revolve around the nucleus, everything, potential energy is equals to 2 times of kinetic energy, which is equals to 2 times of total energy. That is what you have to remember, all of you. Potential energy is equals to 2 times of kinetic energy, and or else which is equals to 2 times of total energy. That is equals to potential energy. So always, if it is the bounded, so closed path, if it is revolving, elliptical or circle, always the total energy is